Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. And today, we're going to be looking at a problem involving approximating an integral using subintervals and the areas of rectangles. So, if you've got any questions about this problem, please feel free to put them in the comments below. And if you have any other problems that you'd like to see, please put them down there as well. So let's jump into this problem. We're asked to use 4 subintervals and midpoints to approximate the following integral. You don't need to go beyond your initial expression to simplify this, and no rule is specified for f of x, so your answer will be left in terms of that. And we've got our integral. So one of the things you learn early on in integration is that the integral, one of the ways you can see the integral is that it is the area underneath the curve of anything. So what does that mean in terms of, what we're going to be doing here? Well, we've got our integral from 2 to 5 of some function. And we're going to be approximating that by a sum. And here's what the sum will look like. It'll be the summation from I equals, let's say 1 to n, of f of x sub I times delta x sub I, where I is the subinterval we're in, and the delta x sub I is the width of each subinterval, and the function then is going to be the height of each rectangle that we're going to be finding. In our case, our delta x sub I is going to be fixed. That's not going to change. So we could actually write this out as the summation of the function at x sub I times delta x, where delta x is equal to b minus a over n. It's going to be the right endpoint minus the left endpoint divided by the number of subintervals. So let's get a picture now of what we're going to be dealing with here and figure out the pieces that we're going to need for our problem. And so I'm going to draw out a coordinate plane and put in some hash marks and the function. Okay, so now we've got our hash marks and a curve. That pink line is going to represent the function that we're working with. We have no idea what it is, but we can just make something up, something that's going to be easy. And now our task is twofold. We need to come up with where the rectangles are going to be. How far do they go out? Do they go from 2 to 3, or do they go from 2 to 2.5, or whatever it is? And then to figure out our x sub I values. So the values that we're going to use to figure out the height of each of our rectangles. So to figure out how wide the rectangles are going to be, we're going to be using delta x. And we'll actually be able to get a value for that. So delta x, let's put that over here, delta x is equal to 5 minus 2 over the number of subintervals, which is 4. So delta x is equal to 3 over 4. If you want a formula to figure out where the edges of the rectangles are, there is one. Each edge, I'll just call it the edge here. Each edge is equal to your starting point. So it's going to be your left end point plus I times delta x. But I think you'll find that it's just as easy just to kind of to figure it out as you go instead of trying to use a formula. But you can use it either way. It doesn't really matter. We know we're going to start off at 2, and then the edge of our rectangle is 3/4 away. So we're going to add 2 plus 3/4. So 2 plus 3/4, if you want to go with fractions, so it's 8/4 plus 3/4, so it's 11/4. And then we're going to add 3/4 to that. So 11/4 plus 3/4 is 14/4, which is 7/2. 14/4 plus 3/4 is 17/4. So that's right here. And then 17/4 plus 3/4 is 20/4, which is 5. So there's the widths of all of our rectangles. And we've got 4 of them. And here's the first one, the second one, the third one, and the fourth one. So how do we figure out the middles for each of those? Well, the easiest way, well, Not necessarily the easiest way, but one of the ways to do it, probably the way we're going to do it, is to find the average between each endpoint of each interval. So the middle here, which I'll put in blue, so the middle right here, that point is the average between 2 and 11/4. So I'm going to make a little table so I can keep track of everything and find the average between each pair of endpoints. So just to be clear, what I'm going to be doing is, and I'll work this out and it'll be edited out, but all the numbers will be there. What I'm doing is I'm taking 2 plus 11/4 and dividing it by 2, and that'll give me my first midpoint. And I'll do the same thing for each one of those. Okay, so there's all of my midpoints. And those are the values I'm going to be using to plug into my function to find the heights of each rectangles. So what that means geometrically is I can take and make a rectangle that goes between, for the first one, between 2 and 11/4. To figure out how high this rectangle is going to go, I have to use a point somewhere in that interval. And the problem asks us to use midpoints. So I'm going to use this midpoint here, and I'm going to go up to where that midpoint tells me to go on the function. That point is going to determine the height of my rectangle. So I'll bring it all the way up to there, like that. And we can do that with each subinterval. So now we just need to fill everything in. So we've got our summation from I equals 1 to 4 of f of x sub I times delta x. And once we start to spell this out and put in our delta x, which is 3/4, then we get something that looks like this. So this tells me that the summation is equal to the function at each of those midpoints times the width of each interval. And you can take and pull that 3/4 out if you like. There's no problem in doing that. The problem just says leave it at the initial evaluation of this problem, and that's what we have here. Now, if you actually had a function that you knew, like x squared plus 1 or something, you would plug in 19/8 into x and then square it, add 1, and then multiply that whole thing by 3/4, and that would give you the area of the first rectangle. And then you would do it for the second. It's very tedious, but it's very doable. It's just a matter of plugging that stuff into your calculator. So I'll leave that here, and thanks for watching, and I'll see you for the next problem.